Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Welcome, everybody, to today's episode of Pepperl+Fuchs Plugged In podcast. And today I have with me Corey Akunzi. Hello, Corey.
Hello, Helga. How are you today?
I'm doing just fine, Corey. Thanks for asking. Corey, what did you bring today? What are we discussing?
So today I wanted to talk about our new redundant encoder for safety applications that runs on the CANopen network.
Yeah, of course, Corey. You're right. That's good to know. So let's start by looking at why do we have this product? Why are we offering it? Why do our customers need this product?
So we have this encoder for customers that need to integrate an encoder into their safety system. They're still going to need a safety PLC, but this is what we call a safety-ready encoder, which means that it should be fairly easy to integrate into a safety system.
Okay, at this point, I think we need to talk about what it means to be safety-ready. Can you give us some details and some examples?
Yeah, so by being safety-ready, this encoder, for example, has what we call diverse redundancy, which means that there's basically two encoders in the same housing. We have an optical encoder and a magnetic encoder. So you have two separate outputs. And the reason for this diverse redundancy is so that you won't have a common mode failure. Let's say that you have a system that has two magnetic encoders or two optical encoders. If there's something that causes a problem in either one of those encoders, it's going to cause it to both. Where if you have an optical and a magnetic, what you have there is if there's a problem with one, you still get the data from the other. And that'll say there's a discrepancy in the data, and that will cause a sort of red flag so that people go check to see, make sure everything is okay.
Yep. Yeah, I mean, the idea of using diverse redundancy has been around for a very long time. And I think what this product brings to the table is the fact that it is in one housing, and therefore it's improved with regards to simplicity.
Yeah, so you instead of having to have two separate encoders where you have two separate mounts and two sets of cabling, now you have one encoder that fits in the 58 millimeter housing, and it can use all of the same accessories that a normal 58 millimeter encoder can use in terms of the mounting accessories, etc. And at the same time, you have one cable instead of two that you're hooking up to your safety PLC.
And it's more compact.
Yes, because it's one encoder in a standard 58 millimeter housing.
Yeah. Can you give us a little bit of an idea of what this is besides that? So you already said 58 millimeter housing. You know, encoders come in all sorts of flavors: single turn, multi-turn, high resolution, low resolution. What are we looking at?
So we're looking at a very high resolution multi-turn encoder. You get up to 30 total bits of output. And again, like I say, it's got the optical and the magnetic all built into one housing. So you get the two separate outputs. It actually comes out like two node IDs on the same output. So as you're looking at your data coming out of the encoder, you actually see two separate node IDs, but it's all coming from the same basic encoder. And it can be in either a solid or a recessed hollow shaft as well.
Okay. When an encoder is a device that is on the one hand electronic, on the other hand it is sort of mechanical because it connects to something rotational, something that spins. Can you tell us about the mechanical qualities of this product?
So this encoder doesn't have any kind of a rechargeable battery on the inside because the magnetic part of the encoder uses what we call energy harvesting, which means that the rotation of the encoder itself provides enough voltage to get and retain that absolute position. And the optical encoder just inherently is able to store that absolute position. There's gearing on the inside, and there's like a read head on the inside that follows along the code disk. And if the power were to be completely cut, or if this were to stop spinning, then it doesn't matter because it all stays in the same place. So inherently,
it's a true multi-turn encoder that knows its position no matter what happens during the power down stage.
That is correct. Yes.
What about other mechanical qualities, shock, temperature.
So this
I
actually
don't know,
has,
did you mention IP rating already? I'm not sure.
no, I haven't mentioned. So IP can be up to, it can be either IP65 or IP67, which is very good for water ingress protection. And the temperature range is actually fairly high too. It's minus 40 degrees C all the way up to 85 degrees C.
Yeah, minus 40 is very uncomfortable. And 85 C is also quite nasty. So that's a significant temperature span.
Yes, for sure.
I wanted to ask you, coming back to the CAN interface, the encoder as we have it today is CANopen. Is that correct?
That is correct.
What about J1939? Would that be an option?
So it could be, if that's what is needed. There's really no reason why we couldn't do a project, make like a custom applications type project and switch over to J1939 because it's a very similar system to CANopen and it still runs on that CAN bus. So we already have the CANopen data and output. We just have to alter it slightly to get that J1939 output that a customer may be looking for.
Okay, that's good. That's good. So, invitation to our listeners out there: if you have a need for a redundant CAN encoder, but J1939 is what you need, talk to us, please.
For sure.
So, Corey, having said all that, where do you see the applications for a redundant encoder?
So the main applications are going to be where you have to have extremely precise measurement of your location or position. I'd say probably one of the big things is going to be lifting applications like a forklift, where you want to make absolutely sure, especially in a warehouse where there may be some sensitive materials that are sensitive to shock or sensitive to, things that might cause them to have an issue just based on any type of a strike or a shock to it. So you get that very accurate position as to how far the forks have gone up and down and the actual position of the forklift itself, because you can use the absolute encoder to measure how far that the forklift has moved. Another one would be automotive, which is very similar, where if you have, say, you've got cars that have to go around on some sort of a track, you need to lift them from one level to the next level. This encoder will make sure that that position is absolutely precise, so you don't have any kind of a misstep from the tracks not meeting each other. And another application.
So it's not only, if I could just for a second interrupt here, it's not only about making sure that people don't get harmed, even though that could very well be a situation, but it's also about protecting the machine.
Correct.
And therefore assuring that you have maximum throughput because you have reduced downtime.
Exactly. And it's also about preserving the goods that you are transporting as well to make sure that there's no damage done.
And you were going to, and you were going to give us a third example of where you see this being used.
Yeah, a third example could be like, say, a wind farm where you've got these giant windmills up on top of the pole, and you want to have a precise calculation of which way it's turned, that whole entire nacelle as it's turned from one direction to another. So you know exactly what direction the wind is flowing, and to make sure you get very precise measurement on that.
Great. So you know what's coming next, Corey. While I try to summarize our conversation in a couple of sentences, you think about our famous, I hope by now famous, 5-word statement. There's about, more or less 5 words to summarize the main point, the main takeaway from our conversation. So let me give it a try, and you also chime in then at the end where I missed out. So we are talking about, today we're talking about a redundant encoder with a CAN interface, and the unique piece is that this is a singly housed encoder that behaves to the control layer as if you had 2 diverse encoders in one. This gives us the ability to utilize our safety-ready concept, where as a result of this, we can be very certain that the data that comes out of the encoder is being proper. So common mode errors are being caught by the safety control that ingests the information. Applications are lifting equipment in automotive or forklift, and also wind farms you identified as a possible scenario where this product could be used. The encoder works at a wide temperature range from minus 40, I believe, up to 85 Celsius. So quite wide, quite uncomfortable temperatures. I don't want to be there. And the resolution is very, very high.
Correct.
I think that's probably the main points, right?
Yeah, that's all the main points that I wanted to cover today.
Great. So what is your 5-word statement today, Corey?
So my 5-word statement for this encoder would be diverse redundancy makes safety simple.
Nice. Diverse redundancy makes safety simple. Safety system simple. Very good. Well, Corey, as always, I really appreciate that you talked to me today, that we were able to record this episode of Pepperl+Fuchs Plugged In. And we hope that everybody out there got something out of this, and we hear you soon. Bye-bye. Take care. Bye, Corey.
Bye, Helga.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.